Welcome listeners to the next topic of our discussion, that is petroleum, and again it's a part of our discussion in the series of lectures on fundamentals of geology. So talking about petroleum again, apart from our discussion that we had on coal, now the other fossil fuel that is extremely important for our energy industry or the energy supply and our sustainability is your petroleum. Like you drive a car, or you are going by a train, or even you are taking a flight to somewhere to travel, you are obviously dependent on your day to day life for your transportation purpose. Apart from that, there are other applications as well. So be it your petrol, that is petrol or diesel that is running your car, or your diesel engines of your trains, or even your white petroleum or very high grade, you can say very pure kind of petrol or gasoline that is used of your means in your airways, mainly in your flights. So obviously we are using knowingly or unknowingly, we are using petroleum in our daily life every day. So petroleum is nothing but a thick, flammable, yellow to black mixture of solid, liquid, and gaseous hydrocarbons that occurs naturally beneath the Earth's crust, similar to that of your coal. Coal also occurs beneath the Earth's crust. So again, petroleum is a thick, flammable. Remember, it's flammable, readily flammable, yellow to black mixture of solid, liquid, and gaseous hydrocarbons, and occurs naturally beneath the Earth's surface. To you can say, to light up a coal, you will need much more energy or heat to light up or to burn a coal, but to burn petroleum, it is quite easy to burn some petrol. Simply by using a matchstick, you can burn petroleum. So the formation of oil is related to again three stages. Like again, we have seen the process of coalification. Here the process involves the accumulation of organic matter, followed by diagenesis, catagenesis, and again a process that comes at fourth. We will be looking into that, but that actually goes beyond the formation of coal, that is metagenesis. So here if I again look at the occurrence of coal, then again three types of rocks are actually controlling the production, accumulation, and trapping of your petroleum in a particular region. So the first thing that is important, that is the source rock through which your petroleum is being derived, due to obviously the accumulation of your organic matter, followed by these processes of diagenesis and catagenesis, your petroleum is being formed. Then so that is your source rock, from which it is getting transported into some rocks like sandstone, for example. So your source rock is, for example, shale, from which your petroleum is being derived. Now it is getting accumulated within the pore spaces of a sandstone horizon or a sandstone layer, then such that it gets stored there over a long period of time and does not escape from this site of its occurrence. You need a rock that is a trap rock. You need to also trap this resource, you need to trap this hydrocarbon. So these are the three varieties of rocks. This is the, for example, again is in this diagram you can see source rock, from where your petroleum is being generated. Then you have this reservoir rock of sandstone, where your pore spaces are obviously, if it is in the saturated zone, they are filled up with water. But as oil or petroleum or oil is or your crude oil is relatively less denser than that of water, so it will simply float above the water. And some part, if all the pores are not filled up by petroleum, then also the rest of the pores on the just above petroleum, there will be natural gas. We will be looking into that. And the mudstone here kind of you can say acting like a cap to this system, so that the reservoir having your petroleum and your natural gas doesn't escape from this site unless it is getting trapped, or unless you have a cap rock. Obviously even after formation of petroleum or natural gas, it will finally, you can say, escape from this system. So now for your this thing means oil production, you can drill wells, deep boreholes, you can extract petroleum, you can also pour water through this kind of drill holes. Why? Because as you are continuously producing oil, what will happen? The level of the oil will decrease, obviously. So if the level of the oil is decreasing at a faster production time, and somehow this gas that is present just above, this natural gas that is present just above the level of the petroleum, that comes in contact to the mouth of this drill hole, then there is a high possibility, because that natural gas that is mainly, you can say, dominant in your methane, it will simply burn out the whole drill hole. And even that's why you can say that many petroleum fields are very risky to generate oils, and there has been reports of multiple accidents in a petroleum field over our history of producing oil. So such that this petroleum, you can say, the petroleum level or the level of the oil doesn't come down to such a level that the gas comes in contact with the borehole. Continuously you have to also inject pressurized water, so that it will go at within the reservoir, and leading to what? If the water will increase, again the level of the petroleum will increase. So it will help you to again produce petrol very easily without touching or affecting the natural gas horizon that is present. So now if I look at the processes or stages of oil formation, then I will start with the process after accumulation of your living remains from your living organisms. The process of diagenesis starts. The organic remains like lignin, carbohydrates, proteins and lipids, they go into microbial degradation, polymerization and condensation in the process of diagenesis, and that will also remain that will lead to the formation of fulvic acid, humic acid and humin. And finally this transition of the diagenesis and catagenesis process will happen over a material that is referred to as kerogen. So kerogen is a prerequisite for the formation of oil. Unless you can make kerogen, you can't make oil at all. So your kerogen then enters the process of catagenesis by again thermal degradation. You will be developing what we refer to as the crude oil, and again with further you can say cracking of the reservoirs, where you are means simply reserving these hydrocarbons. Methane and light hydrocarbons can also get accumulated in this reservoir rocks. So this catagenesis period or the stage of catagenesis is the main or principal zone of your oil formation. Then from catagenesis to metagenesis, this transition marks the main zone of gas formation, and finally whatever organic material is left, it will be completely segregated out as simple carbon residue. So and also there are some associated processes that if there is some minor alteration of retaining carbon skeleton, they can lead to some geochemical fossil fuels, and they can also get transformed under the process of diagenesis and catagenesis into the formation of crude oil. So again if I look at this chart or graph, I can say this is the window of the formation of oil, that is mainly within the domain of catagenesis oil window. That means where the temperature is between, for example, 60 degrees centigrade to 160 degrees centigrade. Between this temperature zone you will get oil, or this is most favorable for the formation of oil. If you increase the temperature more, then the same material will now get transformed into gas, which is obviously natural gas. So this is again temperature range of 160 to 225 degrees centigrade will give you a window of gas. So at this temperature mainly your natural gas will be formed. Again in the process or transitioning into or in the later part of the process of catagenesis, transitioning into metagenesis, when finally even it will, the carbon remains, or the your organic matter will only give you some carbon residue, and your oil and gas will, at this level, it will be segregated to much lower temperature. So this is the oil window and the gas window with respect to the you can say the process of the subsequent processes of diagenesis, catagenesis and metagenesis. And the depth, obviously we are referring to depth as well, similar to that of coal. With higher depth you are going for higher rank of coal, here with higher depth you are going from oil to natural gas. So here again, if I look at this oil window, it is the central part of the oil window is about your 3 kilometers or 3000 meters. So that will also give you an idea of how this kind of oil gets formed from the organic matter. And at the metagenesis level, again you will only get this carbon residue in form of graphite. Now, like I was mentioning kerogen, that kerogen is the prerequisite for formation of petroleum or crude oil. So kerogen is a waxy, insoluble organic substance that forms when organic shale is buried and heated. It's a major step in the formation of oil and natural gas. So again, if I look at the varieties of kerogen, then I can say, based on, again, like we discussed about the different types of macerals based on the ratio of oxygen carbon on one side and hydrogen carbon on the other side. Similarly, kerogen can be also grouped into these 4 types. Out of this, you can see these blue ones will contain only carbon dioxide and water, like this, and this part will be your oil in all the 3 types, type 1, type 2, type 3. So in all these cases, your hydrogen and by carbon ratio is relatively more in comparison where there is no hydrocarbon potential. So if the oxygen by carbon is more, then that means there has been more oxidation. So if the oxidation is more, you can't really generate, be it your petroleum, or even if the oxidation is very high, you can't really generate coal. So you can say this fourth type of kerogen having high oxygen by carbon ratio, here you will not get any kind of petroleum occurrence. And here this kerogen, you can see, is giving you a direction of the maturity. So as long as the hydrogen by carbon ratio is increasing, you are going towards higher maturity of kerogen, leading to formation of petroleum and natural gas. So these are the 4 types of kerogen. Again, based on this hydrogen and oxygen index, the same thing has been depicted here, but I have just put this source organism here to have an idea about the source material as well. So in case of type 1 kerogen, the main organic source is your algae or planktons. For type 2 kind of kerogen, you have bacterially degraded algae or mixtures. For type 3 kerogen, you have your source of organism is your resin, cuticle and spores. And for natural gas, finally, you have some cellulosic tissue or wood, and the rest is nothing but your carbon in the metagenesis process will lead to the formation of your graphite. So, and it will not have any kind of oil potential, but in this part, type 3 kerogen will give you an gas prone area, or it will lead to the formation of natural gas. In case of type 2, mainly you will get waxy oil and condensate prone, and the type 1 and partially 2 as well will give you a very oil prone area. That means the kerogen of type 1 and type 2 with high hydrogen and by carbon ratio will give you the chance of occurrence of a petroleum more in comparison to where your hydrogen carbon ratio is low in case of type 4. Now kerogen again can be depicted in this the maturity of the kerogen can be depicted in this simple figure, where if lithium is present in the pore spaces like this, so your immature kerogen will release this organic lithium, and will be finally it will try to leave this system, leading to the maturity of the kerogens. So, kerogen conversion in this geological system with increasing pore space, leading to again, if the pore space is quite high, it will lead, there is a probability that the permeability might also become high if it is not shale. For example, shale has very high porosity with almost no permeability. So, in this case, if the porosity is gaining, there is a probability still that there are connected pores also, which will lead to an enhanced permeability, which will be also can be this porous and permeable layer might act as a good reservoir like that of sandstone for trapping oil. So, now if I look at a typical oil reservoir, then again these are the three kinds of rocks that we were discussing: source rock, reservoir rock, and cap rock, that what combines and form an oil trap. For example, so if you have a source somewhere, then obviously some oil shale, or in some cases limestone, can also become a source and reservoir rock as well, though it has relatively less porosity in comparison to sandstone. But sandstone are always very good, you can say, reservoir rocks, and for cap rock you need again a kind of low porosity rock as your cap. Unless you have a low porosity as your cap rock, your oil or natural gas will escape from the system. So, your oil is trapped by an impermeable cap rock and rests within a porous reservoir rock. So, you can produce oil when you are penetrating into the reservoir rock. You can get dry well with no oil supply if you have drilled hole till your cap rock. So, again there are various type of traps, just to mention the most common types: anticlinal traps, which are obviously related to your deformation; folds will form; fall traps, again related to deformation; stratigraphic traps, obviously based on the principles of stratigraphy we discussed much earlier. Stratigraphic traps, like you have horizons of this shale, sandstone, sometimes some, you can say, sandstone, shale, limestone horizon. Again you can say sandstone, shale, or shale, limestone, and your shale, sandstone horizon. So, always if there is a sandstone and limestone horizon, they are intermediated or alternated by a intermediate shale layer. Remember, always sandstone and limestone cannot occur simultaneously. So, you have to have a layer of shale in between because of their depositional environment, nothing else, because of their depositional environment. So, if you have, and also sometimes pinch out traps. So, if you have a trap like this that looks like a antiformal fold, and if it is stratigraphically, if it is also anticline, then can be referred to as under antiformal anticline or anticlinal traps like this. Faults can also, because faults are good at you can say limiting things, because if there is a fault, there will be a limit to the horizon on the both side. So, your gas or oil can get trapped just adjacent to a fault. Stratigraphic traps are nothing but they are simple horizons of impermeable material, so that it can act as a cap. And sometimes some pinch out traps, mean pinch and swell structure, there are some pinching in the stratigraphic horizon. There also there are some spaces where you can store or reserve, or that part might act as a reservoir rock for your petroleum. So, these are the different kinds of common traps that we get to see in a petroleum field, but always remember, there has to be a source rock that will produce the oil, then there will be a reservoir rock which will contain or store the oil, and to restrict its migration from its place of occurrence, you need a cap rock. Just to give you again an example, that like all deltaic regions, or in, you can say, Gulf regions like that of the Persian Gulf, which dominates the world oil production, because the Persian Gulf contains more than or near about 60% or a little bit more than that of the global oil reserve. So, these areas are very favorable, this Gulf or sometimes deltaic environment are very favorable for this kind of accumulation of organic material and then subsequent transformation into oil. Just to cite an example how important cap rocks are, in the Bengal basin of India, it was proposed by earlier by different scientists and some people from ONGC as well, that is the Oil and Natural Gas Corporation of India, that there is a huge probability or there is a huge potential of oil in the Sundarbans and the Bengal basin area. But after detailed analysis and detailed research, it has been found that though there are this source rock and reservoir rocks are available in this region, but due to due to an absence of any specific cap rock which can really trap these oils or natural gas, the oil that might have formed in these places, because in these places of your Bengal basin there are very suitable source and reservoir rock, but due to the absence of this cap rock, this petroleum that possibly has formed over a million years of time has now escaped that area and has flown to somewhere else or simply escaped the system. So, that is why you need always to have a cap rock, so that you can retain whatever oil is being generated during the process of this transformation. So, whatever process during this diagenesis, catagenesis and metagenesis processes, whatever oil is being produced, you need to put a stop to its escape by utilizing the cap rock. So, you need to always have a cap rock if you want to means you can simply store a petroleum reserve for a long span of time. Then other reservoir characteristics that are important. So, your reservoir rock should be having high porosity, like I was taking the example of sandstone. Sandstone always serves as a very good reservoir rock with high porosity, permeability, reservoir pressure should be optimum, and your fluid properties like the characteristics of the oil and associated fluids such as viscosity, which affect the production and your processing. So, you can have these different examples: A, the impermeable shale clay which is acting as a cap rock; B, that is the porous reservoir rock, for example your sandstone; and C is your source rock. So, you can very easily trap this kind of oil into this with a cap rock sitting above as A, reservoir rock sitting below as B in the intermediate level, and again underlain by the source rock, that is your C, and D is obviously where you are drilling a hole to take out this oil. Similarly, in case of a fault trap, you can get this kind of a scenario. Then in case of salt dome traps like this, you can have faults like this and oil and natural gas present here. Still, you need to have your cap rock, reservoir rock and source rock, and these are an example. This is an example of a stratigraphic trap. So, again talking about cap rocks, like I was mentioning, it is very important. So, cap rocks can be of a variety of types: salt cap rock, shale cap rock, then anhydrite cap rock, basalt cap rock, limestone cap rock. So, these are always though some of them are partially porous, but these are impermeable completely in nature with extremely low porosity and almost no permeability. So, these rocks will act as the most favorable cap rocks for a oil field or an trap. So, oil trap. So, the characteristic common to cap rocks are, again to summarize, these are impermeable rocks, compacted rocks, overlying reservoirs and resisting any kind of deformation. If there is deformation or some kind of you can say disturbance in this particular petroleum system, again the possibility of escaping of the natural gas or the petroleum will arise. So this is again the distribution of all oil resources across the world, and you can see this dark region in the Persian Gulf, United Arab Emirates and all other Arab countries. They actually have the most about more than 50%, nearing about 60% of the oil reserves on earth. Then other countries like USA and parts of Eurasia have also potential oil reserves. Talking about now natural gas associated with oil. Natural gas associated with oil refers to the presence of natural gas formed in the same geological formation as that of the crude oil. Like we have seen earlier, always natural gas is simply present above the crude oil. So natural gas and crude oil often form together through the same geological process of your diagenesis, catagenesis and metagenesis, but at different temperature condition, sometimes different depth of burial as well. So both natural gas and oil can originate from the same source rock, typically organic rich shale or limestone. So again you can see that always natural gases are topping the oil fields that are present. So if you have a sandstone reservoir like this, anticlinal synclinal trap like this, you have this oil and the natural gas will just sit above this. And this is again the distribution of oil fields in India. Again the majority or the most, means you can say the most part of the oil reserve of India comes from the western shore, about your western offshore near the Bombay High region, and some other oil fields as well, which have a percentage of 33.2% of the total Indian oil reserve. In Rajasthan and Gujarat also there are oil fields which also jointly they contribute about again 33%, and the rest of the oil fields apart from Assam, where actually oil was first reported from India, that was Assam. You have also a contribution of about 22 or 23% from Assam, and the rest are in the eastern coast in Tamil Nadu, Andhra Pradesh and eastern offshore. So these are the oil reserves or the potential oil fields in India. But just to look at this consumption and production of oil in India, so you have a more or less steady production, a little increase in the production of oil for you can say last 30 years, but there is a steep increase in the consumption of the oil in India in the last 30 years. So 75% of the oil that are consumed in India are being imported or are bought from your these Arab countries and Russia. So the future, apart from coal and you can say petroleum, the future that we are now looking forward as a country as well is your hydrogen fuel. So the hydrogen economy or the economy of hydrogen is a vision that uses hydrogen as a low carbon energy source, replacing natural gas, gasoline and even coal. So hydrogen fuel is used in fuel cells to create electricity. So there are various kind of hydrogen as well, green hydrogen, blue hydrogen and gray hydrogen, and is also mixed with CNG gas to improve its efficiency. Why it is beneficial over your natural gas, petroleum or combustion of coal? Why? Because it has very low emission. Hydrogen reduces carbon dioxide particulates and also nitrogen oxide emissions compared to the combustion of the engines. The air quality will be improved, then high reliability because hydrogen fuel has high calorific value as well, and it has means kind of it is quite flexible to install a hydrogen fuel station, and definitely it's a renewable energy source because hydrogen is present in your water molecules also in you can say the hydrogen is obviously the most dominant element on the in the universe. and obviously it will lead to the reduced demand of the 75% of oil import that we are currently going through, because only 20 to 25% of the consumption of fossil fuel is being supported from the production or the Indian production. The rest 75% we are dependent on other countries across the globe. So it will reduce that import, and also it will promote a much more clean energy, that is your hydrogen energy, and that will lead to obviously what we are now referring to as the hydrogen economy. So here I would like to end my discussion on petroleum as well. Thank you.